Hello and welcome to a tutorial about fractional distillation this time. So very similar to the principle we looked at with simple distillation. However, there's just one slight difference with the equipment. So this time, if we look at the two pieces of equipment, this one was our simple distillation and the one on the left is our fractional distillation where we have a fractionating column this time. Okay, we'll have a look at what the use of that is and why we use it. So fractional distillation is mainly used in the crude oil industry to separate the different parts or fractions of crude oil. And it relies on all those different fractions having different boiling points. And what we're going to look at today, though, is just a more how we would use fractional distillation in a school setting. And that's to separate two liquids that have very, very, very similar boiling points. They've got to be different, okay, for them to be different liquids, but they are very similar. Okay, I'm going to run you through a quick model now to explain the purpose of having that longer fractionating column. Let's have a look. So if we have a look at this example, we've got two vehicles, one big, slightly slower lorry and a small, slightly faster car. So if we go with our original simple distillation column, which was very short, okay, let's see what happens. Okay, you can see that even though the car is a lot faster over a very short distance, they both seem to reach the end at a very similar point. So if we change our column now for a slightly longer one, okay, let's see what happens. So over a longer distance, the smaller, faster car reaches the line first. So we've got a very clear separation. Now, if we turn that into a bit more scientific, so with our molecules, so the small molecule is a slightly faster one compared to the car. The larger molecule would be like the lorry, slightly slower. Okay, same again over a short distance, there's very, very little separation. If we increase the distance that they have to travel, the small one reaches the end first. So we've got a clear separation. So just relating that to our equipment now, this is our simple distillation equipment. Okay, they will both kind of boil and reach the condenser at the same time, so we wouldn't get any separation. All they would do is both of them would go through the condenser, condense back to a liquid, and we would have just moved them from the flask to the beaker. If we now use our fractionating column, you can see that one of those substances would reach the condenser before the other one. So we will get a clear separation. So just as a quick summary, fractional distillation separates two or more substances from a mixture, so same as the simple distillation, and it does rely on them having different boiling points, so exactly the same. Apart from this time, we can separate liquids with very, very similar boiling points. For example, ethanol boils at 78 degrees Celsius, and water boils at 100 degrees Celsius. So if we heated it up, the ethanol would evaporate first, and it would go down the condenser, and we would get the ethanol in the conical flask, and the water should still be left in the round bottom flask. So it just improves the separation of the mixture, basically because the larger the tube, we've got a larger surface area on which the vapors can continually condense. The water would come back down, and the ethanol would go into the condenser and condense back to a liquid. Thank you.